In this tutorial, we're going to take a look at some examples, 5 altogether, of multiplying and dividing rational expressions. So in A, we're going to start with something on the smaller side, that this just has monomials in it, and then afterwards we'll get to binomials, trinomials in the numerators and denominators. So if you have something that's squared or cubed or something like that, it'd be a good idea to evaluate those powers first. So if I square 3x, 3 squared is 9, x squared is x squared. And then in the denominator, 2 squared is 4, and x squared is x squared. Common mistake here is to forget to square these like 3 and 2, and just write like 3x squared and 4x squared, but everything in the brackets gets squared. Nothing to evaluate here, 12x squared, y squared, and the 3x in the denominator. Now, at this point, there's 2 things you could do. You could start dividing things out. For example, I could, for example, go 3 goes into 9 3 times. And then we could say this 4 goes into 12 also 3 times. I could say, okay, this x squared divides into this x squared. Let's see now, I could divide this y into this y squared, leaving just a y here. And I could divide this x into this x squared, just leaving x. I'll scratch the exponent. And let's see now, what have I got left here? So I have 3 times 3 is 9, and then this x and this y. And that works, but it can get complicated. There's quite a bit there, and it's easy to miss something. So there is a little better way to do it. So remember the answer 9x. Well, I'm going to erase all my writing and show you a little more structured way to do this. And so what you can do instead is multiply the numerators together in the numerator and the denominators together in the denominator. And so 9 times 12 is 108. X squared times x squared is x to the 4th. And then we have a y squared. 4 times 3 is 12. X squared times x is x cubed. And then a single y in the product in the bottom is y there. So now there's less to divide out. There's not like dividing across here and that kind of thing. So 12 goes into 108 9 times. So 12 goes, so there's a 9. I'll write my 9 up top somewhere. X cubed divided in x to the 4th leaves a single x. 4 minus 3 is 1. There's actually a power 1 here. And y goes into y squared. Those divide out, leaving a y as well. 2 minus 1 is, there's a 1 here. So 9xy. Remember, that's the same answer we got a moment ago. So that is 9xy is a simplified version of this. Now restrictions. I'm going to list restrictions for all of these. And in this case, the restrictions are the variables x and y both can't be 0. And what you do is you look at any variable that was ever in the denominator, and actually the ever part doesn't really apply in this one, but when we get into dividing, I'll explain that in another page. You see we have x and y both in the denominator here. I'm not really looking at the x and y here. It's any expression or variable that was ever in the denominator can't have a value of 0. And so you see, I had once upon a time, a moment ago, 12x cubed y. And so if x was 0 there, this would have a value of 0, and you'd be dividing by 0, and that's a no-no. You can't divide by 0. And the same with y. If y had a value of 0 here, then this would also have a value of 0, and again, it'd be undefined. So the restrictions are x and y both can't be 0. They're not always 0, okay, but they often can be, especially when you have monomials. We'll get into some non-zero ones in a moment in B here. Now in B we're going to start, see I have a couple of binomials here. Okay, so we have to start doing some factoring as soon as there's more than monomials. So the 2a plus 6, there's a common factor of, and when you're factoring, always look for a common factor first. Common factor of 2 in the top here. So I can factor a 2 out of this. So if I factor a 2 out of a 2a, I get a, and 2 out of a 6, I get a 3. And then over here in the numerator, now there's just a 3. There's nothing to factor there. But a squared minus 9 is the difference of 2 squares, and that's why you need to know all those factoring patterns and strategies. It's a squared minus 3 squared, so this will factor into a plus 3 and a minus 3. And so notice we have an a plus 3 in the numerator here, and an a plus 3 in the denominator here, and so they will divide out. A plus 3 divided by a plus 3 is 1. If that goes back to the rule where something divided by itself is 1. And so that's why we don't need to write an a plus 3 in the numerator and the denominator, because it just divides out to 1. So what's left here, and that's the only thing that divides out here. In the numerator, we have 2 times 3 is 6, so a 6 in the numerator, and 7 times this a minus 3 is left in the denominator. And so that's the answer, the simplified version of this. Now, restrictions. A can equal, now, plus or minus 3. Now, you don't just look at this factor here. See, it would be 3 here. 3 minus 3 makes that have a value of 0. You see, any factor that was also divided out that was at least once upon a time in the denominator will also give you a restriction, because you see, if a was negative 3, so if we put negative 3 in place of a here, then this factor would be negative 3 plus 3, which would give you a value of 0 in the denominator. Again, it's undefined. See, so that's the negative 3. The plus 3, you see, if we put 3 here, 3 minus 3 is 0, so again, that would have a value of 0, so it's undefined. So those are the restrictions. A can't be 3 or negative 3, because it would make parts of this undefined. You see, this would have a value of 0 if a was 3 or negative 3. If a was positive 3, this would have a value of 0. If a was either, see, 3 here or negative 3, either one of those squared makes 9, minus the 9 gives you 0, so again, that would make that undefined. So those are the restrictions, plus or minus 3, or 3 and negative 3. On to the second page, we're going to do some trinomials here, and then in the fourth one, in D, some dividing 2. So in C, we have all these, and a lot of people call these simple trinomials because they have a 1 in front of the quadratic term, 1x squared, 1x squared, 1x squared, 1x squared. So the factoring is fairly short. So in the first one here, I want to find two numbers that add to 8 and multiply to negative 9. So add to 8 multiplied to negative 9 would be 9 and negative 1. So we would factor into x plus 9 and x minus 1. What adds to 6 multiplies to 9? That's 3 and 3. So this is going to factor in x plus 3 and x plus 3, or you could write x plus 3 squared because they are the same, times. Now this one here, we want to find two numbers that add to negative 2 and multiply to negative 15. And so look for factors of negative 15, and those are negative 5 and positive 3. Negative 5 and 3 add to negative 2, and they multiply to negative 15. And the last one, we want to find two numbers that add to 4 and multiply to negative 45. So negative 45, it's going to be positive 9 and negative 5. So x plus 9, x minus 5. So the reason we want to factor is because you can only divide out whole factors. Okay, a common mistake in these is to do this and say, oh, well, let's see here. I see an x squared on the top and an x squared on the bottom, so why don't we divide those out? Oh, we see another one over here. Those divide out, and you can't do that because they are parts of something that is terms that are added together. That's like saying, let's see now, I have 26 divided by 22. Okay, let's say I had the fraction 26 over 22 and say, why don't I divide this 2 into this 2? So it's 6 over 2, so that equals 3. Okay, so that would be like doing that. And hopefully you can see that that's pretty ridiculous. You can't just divide those 2's out and say that 26 divided by 2 is 22 is 3. Okay, that just doesn't work. So you have to factor and divide out entire factors. So for example, this x plus 9 and this x plus 9 will divide out. They can be top and bottom here or across here, any top to any bottom, and a big product. We also have this x plus 3 here and this x plus 3 here. And of course, I could instead cross this one over if I wanted to. It wouldn't matter. And of course, also the x minus 5s. This x minus 5 will divide it with this x minus 5. And then all I have left in the numerator is x minus 1, and in the denominator, x plus 3. And since there's a single binomial in each, we don't need the brackets anymore. So it's just x minus 1 over x plus 3. Restrictions. The first restriction I'll use is right is negative 3, because negative 3 makes this 0. And if you're not sure about restrictions, what you do actually is you take that factor and say, okay, so x plus 3 can't equal 0. So if I solve for x, okay, so x can't equal -3. So that's where that -3 comes from. So for example, you see there's an x plus 9 that was divided out here. So if I go x plus 9 can't equal 0, so I'll solve for x. So x can't equal -9. And so that's where the restriction -9 comes from. And then I also have this x minus 5 factor. X minus 5 can't equal 0, so x at 5 to both sides can't equal 5. So that's my other restriction. And that's all of them. There were actually 4 factors in the bottom here, but you see these were the same, so same restriction for both of them. So that's why there's only 3 different restrictions here. D, first division. We'll get into another division in the next page too. So again, we have to factor. Okay, so the first one here, x squared plus 3x plus 2, what adds to 3 multiplies to 2 would be 1 and 2. So that factors in x plus 1 and x plus 2. No common factor there, but there is in the denominator. See, we can factor an x squared out of this. So let's factor an x squared out of this. X squared out of an x to the 4th gives you an x squared, and x squared out of minus 4x squared gives you a minus 4. Now, x squared minus 1, x minus 2, so there's a -1 here. And so I'm looking for two numbers that add to -1 and multiply to -2. And so that would be -2 and positive 1. And the last one here, I want to find two numbers that add to -6 and multiply to 8, positive 8. Now, if it adds to negative and multiplies to positive, then they both have to be negative. So it's x minus 2 and x minus 4 that add to -6 and multiply to -8. Now, division. I still have a little bit of factoring left to do here too, but we'll get into division in a moment. See, this x squared minus 4, it's a difference of two squares, just like there was a difference. There was one of those, what was it, x squared minus 9, I think, on the first page. So that will factor into, and actually, I can divide these out. I forgot I was doing that next. You see, I have the same thing top and bottom here, and it doesn't matter that's division. I divide those out, and it's really just x plus 1 over x minus 4 over here. So let's get back to this factoring here. This will factor into x minus 2 and x plus 2. It's a difference of two squares. 4 is a perfect square. It's 2 squared. So x minus 2, x plus 2. Now the division. The way we divide fractions or rational numbers is division is the same as multiplying by the reciprocals. Notice that the x minus 4 is now on the top, and the x plus 1 that was in the numerator is now in the denominator. So we change division into multiplying by the reciprocal. Now, we've got more things we can divide out. So notice that these x plus 2's here are the same top and bottom, so we'll divide those out. And this x plus 1 will divide it with this one. So, the only thing left in the numerator is the x minus 4. I can leave that without brackets, but in the denominator I have x squared times x minus 2. Now I guess you could multiply together, but oftentimes you actually want these things left in factored form, especially when you get into studying rational functions. So I generally tell my students just leave it in a factored form. Restrictions. So we've got this x squared here, and the number that makes that 0 is 0. 0 squared makes 0, so x can't be 0. And then we have 2 here, so 2 from this one. And it's actually plus or minus 2 because you see this factor that was divided out, -2 plus 2 makes 0. So that -2 would be give you a 0 for that factor. And then we had the x, see the x minus 4 is in the top now, but it was back in this line in the denominator. So see 4 would make that a value of 0. 4 minus 4 is 0, so 4 is another restriction. And then this x plus 1 that was divided out, -1 makes that 0. Remember, you set that equal to 0, so we go x, I should set equal to 0, say it can't equal 0. X plus 1 can't be 0, so x can't be -1. And so that's why -1 is another restriction. And on to the last example. So this is a longer one. Got lots of trinomials into factor and not simple trinomials. Got some division, got some multiplication. So the first thing I would do, I'm going to just start at the top here, and we get to factor all these things. So the 3m squared minus 7m minus 6, I'm going to factor that first. I'm going to use the decomposition method. So I want to find two numbers that add to negative 7 and multiply to negative 18, because 3 and negative 6 multiply to negative 18. So adds to negative 7 and multiplies, that's not an x, supposed to be multiplication, to negative 18. And so the numbers that do that would be negative 9 and 2. Adds negative 7, multiplies negative 18. So, negative 9 and 2. Now, there's a common factor here of a 3m. So we're going to factor a 3m out of this, and we can actually factor a 2 out of this. So if I factor a 3m out of this, 3m out of a 3m squared will give you m. 3m out of a negative 9m will give you negative 3. And then factoring a 2 out of this, 2 out of a 2m would give you m. 2 out of a negative 6, 2 divided negative 6 gives you negative 3. Notice the negative m minus 3's are the same. So we can factor an m minus 3 out, and then 3m plus 2 is the other factor. So those are the two factors of this trinomial. So let's start writing this out, m minus 3, 3m plus 2 here. And as I factor each of these, we'll stick them in these spots. So the 6m squared plus 3m. Now this is actually common factoring. I guess I could have just done this here, but I did do it separately here. So it's just common factoring. There's just a common factor of 3m here. We can divide a 3m into both of those. So 3m goes into 6m squared, dividing in 2m times, and 3m divided by 3m is a 1, so plus 1 in the end. So that is what this denominator divides into, or factors into. And there's some common factoring here too. I'm just going to do this straight here. I'm not going to write it down separately over here. We can factor a 3 out of both of these. So if we factor a 3 out of both of those, we get 3 times 3m plus 2. And now this denominator, the 2m squared minus 5m minus 3. I'm going to use decomposition again. Adds negative 5, multiplies negative 6. And those numbers would be negative 6 and positive 1. So there's a common factor here of 2m. We can divide 2m into both of those. So we divide 2m into 2m squared, we get m. 2m goes into this minus 3 times. And then there's no common factor here, so we just put brackets around the m minus 3. And then m minus 3 factors out. Remember, there's actually a 1 here, right here. So this would be 2m plus 1. So those are the factors that are going to go in the denominator here, m minus 3, 2m plus 1. And these are actually both special products in the end here. 9m squared minus 4 is a difference of two perfect squares. See, this is 3m squared, and this is 2 squared in the end. So this is going to factor into 3m minus 2 and 3m plus 2. And the green one in the denominator here is a perfect square trinomial. When you see a perfect square at the beginning, perfect square at the end, it's a good chance it's probably a perfect square trinomial, and I'll show you how you can check that. So it's 2m that's squared here and 1 that's squared here. So there's, like, even just looking at it like this, it's a really good bet this can be 2m plus 1 squared. This is how you check those if somebody hasn't showed you before. See, if we square this 2m, we get 4m squared. If we square 1, you get a 1. I'm going to leave a little blank here, so plus 1. And then you multiply these together and double it, and that should be that 4m term. So 2m times 1 would be a 2m, and then doubled would be a 4m. And that's exactly what we had right here. So that's how you check those. Let's get rid of my writing there. So now that we have everything factored, we can start simplifying. So before we start dividing things out, though, I'm going to change this dividing into multiplying by the reciprocal. So notice the 2m plus 1 squared that was in the denominator is now in the numerator, and this 3m minus 2, 3m plus 2 is down here in the denominator now. Now, what's going to divide out? Well, we've got this m minus 3 here, and this m minus 3 here. They'll divide out. And then we have this 3m plus 2 and this 3m plus 2 over here. They will divide out. And then we have this 2m plus 1. See, there's 2 of those there. So that would divide out with this 2m plus 1 squared, because that squared means there's actually 2 of them here. So that will divide out with the 2 of these. And we're almost done dividing things out, but notice there's a monomial factor of 3 here, and there's this 3m. So this 3 will divide with this 3, and we're done dividing things out. These aren't quite the same. 3m plus 2, 3m minus 2 are not the same, so they will not divide out. But the 3m plus 2 is all that's left in the numerator. And in the denominator, now this m's not divided out, just the 3. So m and then this 3m minus 2. And so that's a simplified version of this big humongous thing here. It did simplify quite a bit. So now let's list the restrictions. So we're going to start first of all from the m here, is that m can't be 0. Now the next one, we've got this 3m minus 2 factor. So if we write 3m minus 2 can't equal 0. So I want to isolate the 3m first. So let's take this negative 2 over. So 3m can't equal 2, and then divide out 3. So that's 2/3 is a restriction. And actually, there's actually a restriction of negative 2/3 as well, because you see that was from the 3m minus 2 factor, but there's also the 3m plus 2 that was once upon a time in the denominator. The only difference is, see, when you solve, say, well, 3m plus 2 can't equal 0, is the sign's going to change here. It's going to be a negative 2 over 3 as well. So that's why there's a plus or minus 2/3. Now from the blue 2m plus 1 here, if we look at the restriction from that one, let's see here, 2m plus 1 can't equal 0, so bring the 1 over. 2m plus, can't equal negative 1, divide out the 2. So negative a half is another restriction. Negative a half. And then last but not least, see this m minus 3 factor that divided out is the only other one that was once upon a time in the denominator. And 3 would make that 0, because 3 minus 3 is 0, so 3 is the last restriction. So altogether there are 5 restrictions for that one. And that's the end of the tutorial.